Hello Internet, Zach here, and welcome back to Collecting the Elements. I know it's been a month and a half since I've added an element to my table, but this one's been tricky. I suppose I shouldn't be too surprised. It gets its name from the German word for goblin. It's a similar story to how nickel got its name. Miners were trying to smelt what they thought was copper ore and were coming up empty-handed. In the case of cobalt ores, though, which they called Kobold ore, the German word for goblin being kobold, they also got a bad case of arsenic poisoning because cobalt ores are rich in arsenic. Now, the pure metal was finally isolated in 1735, though cobalt's compounds have a history dating back thousands of years, being used as a vivid blue pigment, even as far back as ancient Egypt. Now today, cobalt is still used in blue pigments, but it's also used in high-performance alloys, permanent magnets, catalysts, lithium-ion batteries, and it's found in vitamin B12, which is essential to all animal life on Earth. Now, cobalt is one of 3 metals on the periodic table that are ferromagnetic at room temperature. That means not only will the metal stick to a magnet, and vice versa, but the metal can also be magnetized itself. Now, it was recently discovered ruthenium can do this, but only if you get the crystal structure just right. Anyway, without further ado, because, hey, you've already waited a month and a half for this episode, I'm going to get on to showing you how I extracted cobalt from a lithium-ion battery. That was a little more exothermic than I expected. But in here, you might be able to see some bright blue cobalt chloride. And it's bright blue because there's not enough water to hydrate it. Now when I add water to this, it should turn pink. Well, if it's showing up in the sun, kind of pinkish purple. So here's the cobalt chloride made from dissolving battery parts. And I'm going to set up for a simple gravity filtration because there's still some undissolved gunk from the battery in here. Quite a bit of gunk, actually. But that should be done filtering through in a couple of minutes, and I'll be back. Alright, the cobalt chloride is filtered and it's time for the next step. So I'm pouring this off into a glass container because the last time I tried this in a plastic container I melted it. So now I'm going to take aluminum foil, and I'm going to use the aluminum foil to displace the cobalt out of solution. This will cause the cobalt to precipitate as a fine metallic powder. And give it a little stir. Nothing yet. Give it another good little stir. There we go. Now it's starting to react. Alright, I'll be back when this has made a little bit more progress. Okay, it's been about 3 minutes. And as you can see, all but one shard of the aluminum is gone. And let's hold this up. See if I can pull some of the cobalt over so you can see it. But that's the cobalt that was precipitated by the first round of aluminum. So, round 2. All the aluminum has finally reacted, leaving cobalt powder at the bottom, and a bunch of solution that still contains some cobalt, but is going to be very hard to extract on top. So I'm going to filter this out to get the cobalt metal. I am apparently also going to be a total klutz. Now that the solution is filtered through, you can see just how little cobalt that actually is. A rinse with some clean water. Wash down any cobalt that's gotten on the sides of the filter. And this will wash off any remaining solution that's still stuck in the cobalt. This here is my freshly rinsed and cleaned cobalt metal. And this is a concentrated solution of copper sulfate. What I'm going to do is put the cobalt metal into the copper sulfate solution to displace the copper and make cobalt sulfate. Cobalt sulfate is a lot safer for electroplating than cobalt chloride because since I don't have a cobalt anode, electrolysis of the chloride solution would produce chlorine as a byproduct. Electrolysis of the sulfate solution instead produces oxygen as a byproduct, which is, well, a lot nicer to keep around. So, try to carefully scrape the cobalt off of here. Actually, while I still have wet cobalt on a coffee filter, let me take this magnet here. Magnet, cobalt on a coffee filter. That's the magnet sticking to the metal that's in the filter. Quite strongly too. The solution has already gone from royal blue of copper sulfate to looking almost black. There you go. From the cobalt that's gone into solution, it's turned purple because it hasn't displaced all of the copper yet. Now as I shake this up, that there is copper metal on the surface of the bottle now that the cobalt has displaced out of solution. But there's enough stuff suspended, it's hard to show you the color, which is looking a lot bluer on camera than it's looking in person. Anyway, I still have some cobalt left on this coffee filter that I need to get into the bottle. A little bit of plain water to wash the metal down that's stuck. Let's put a stopper in this and shake it up a bit more vigorously. Alright, after reacting and shaking a bunch, see if the camera will pick up the layer of metallic copper at the bottom. Kinda barely. Yeah, there it is. That's all metallic copper that's been thrown out of solution. And there's still enough of it floating around that light doesn't go very far through this. So I'm going to filter this and see if that's fully reacted. Good old gravity filtration. That still looks kind of purple to me. So I'll be back when that's done filtering. This is something that was kind of neat that I thought I would show you in the kind of an intermediate stage in displacing the copper out of the solution. These pieces of metal are attracted to the magnet because they're pieces of cobalt with a thin layer of copper coating them. When they're fully reacted, it'll just be pure metallic copper, which won't stick to a magnet at all anymore. But in the meantime, you can drag bits of copper around with a magnet. Well, bits that look like copper. So I lost the footage of setting up the electroplating setup, which I guess is just as well because, as you can see here, I'm plating copper, not cobalt. Which means there's still a substantial amount of copper in the solution. So I'm just going to keep plating the copper until it's all gone. So this video may be delayed a couple of days while I try to push the copper out of here. Alright, it's taken a couple of weeks to get the copper concentration in my cobalt sulfate solution low enough that I can actually plate cobalt. Notice the color is somewhat redder than it was before. So the way I'm going to do this, I have the handy 12-volt power brick. And to the positive side, I'm going to connect this graphite electrode Okay, positive graphite electrode. And for the negative electrode, I have this piece of stainless steel that I've been using for various electroplating experiments, and you can probably see some of the copper that's been deposited on it when I was pushing that out of solution. And I'm going to plate the cobalt onto this, and when I have a thick enough layer, it should peel right off. Don't roll over. Now, stir that up a little bit. And as you can see, there's some fizzing because I'm pushing 12 volts through this. Eventually I should really build myself a regulated power supply for doing electrolysis. Maybe in the future. But I'm going to let this sit here and electrolyze for a while and come back when I have a nice deposit of cobalt to show you. So this is beginning to acquire a pretty thick coating of cobalt on it. I'm going to take this out of the solution for a moment and filter my solution because, well, just look at this. Let's give this a little rinse. You can see on the back side of the cathode there's some copper that's been deposited that's still in solution and just doesn't seem to want to go away. I'm going to try wrapping the carbon anode in a coffee filter to see if that'll keep the graphite out of my solution and keep my solution looking a little cleaner. Worth a try, right? Well, bagging the anode was a fail. The carbon particles coming off of the anode are so small, they're escaping through the coffee filter. Admittedly, it looks kind of cool. Alright, you might be able to see a faint brownish red cast to this, and that's because there is still a bit of copper impurity, unfortunately. But the cobalt that's stuck directly to the stainless steel cathode should be relatively pure in spite of this, because that should just be a surface layer of copper, because it was plating out pure black earlier. So what I'm going to do to try to liberate the cobalt is first brush off any loose pieces that aren't adhering at all, like so. Pat that dry, okay. Then I'm going to flex the cathode. This should put enough mechanical stress into the cobalt layer that it should start chipping and peeling. So, you should see some bright glittery reflections in there, and those are the surfaces of the cobalt that are actually nice and smooth and shiny. And those are going to be what I bottle up for my element sample. And here it is, the metallic cobalt that I've managed to produce. Come on. Get in there. You know. Alright, shiny. Well, hopefully they'll show up on camera as being shiny. Okay, that was unexpected. Oh well, this one's just gonna look strange. So here it is. Cobalt. In a kind of funny looking ampoule. Well, maybe it's the work of that goblin those miners were talking about. Who knows? And that completes the set of ferromagnetic metals. I hope you enjoyed this episode. If you did, hit the like button. If you know someone else who might like it, hit the share button. If you want to see more, hit subscribe. And if you want to help me make more videos, follow me on Patreon. Anyway, I'll see you next time.